Okay, good morning. I'm hoping you guys had a good day yesterday. This is just a little more on factoring. I just kind of want to get you guys to understand that when you have an expression, you can change it, right? And that's really what you're going to be tested on is your ability to recognize that and do that. So the key is to look for things that I'm just gonna go over something we call factoring trinomials. You'll have an extra worksheet on this today. Okay, so let me show you what this is like. Let's say I had an x and I was gonna multiply it by something called, I don't know, x plus 2, right? So if I was gonna multiply that and I use my regular rules that you guys learned when you were kids for multiplying, right? What you would do here is you would multiply this times this and write it down here. So x times 2, we'd write 2x, right? And then you'd multiply this times that, right? And so x times x would be x squared. And then you would just put a little plus sign because it's a positive in between. Now, what happens is you can look at this in the reverse, right? This is called multiplying, right? And hold on just a second. So here we have x squared plus 2x. So this is called multiplying, right? And it turns out that the name of these things right here, this thing is called the product. The result of multiplying is the product. Okay? But these things right here, this set right here, and this thing right here, the two things that are being multiplied, those are called factors. All right, they're called factors. So if this direction, doing things this way, like this, if all of this process right here you learned and it was called multiplying, then the reverse of this, right? Multiplying creates products. The reverse of this is to take a product and turn it back into its factors. So that's what we're going to do here real quick. Now what I want you to think about, let's see. Remember that we talked about, you can see here that this thing has a 2 dimensions to it, right? That x squared tells me it is not just a one-dimensional product. So I encourage you to think about this as an area, not just a line, but an area, right? And so we have 2-dimensional space here, right? If it's an area, there's 2-dimensional space. And somehow we have to have the dimensions in one dimension and another dimension to make this 2-dimensional. So what I'm going to think about is I'm going to start by thinking that I have some square, right? That is x squared. I see this part right here, right? Actually, let me circle this. Oops, let me get this a little bit smaller. Okay, so here, this is an x squared. So that's an area measure, x squared. And I can really kind of easily know that its dimensions are going to be x times x, right? And the only thing I don't know is this part right here, right? It's a positive 2x. So I just need to stop and think, well, what is 2x? It's 2 times x, right? So I would think this is plus 2 because 2 times x would make this little rectangle over here a space with area 2x. So now my total area is x squared plus 2x. But my dimensions, my one-dimensional linear measures here are x by x plus 2, right? So these are what we call our factors, right? Remember our factors over here, right? We had them over here, and now we've got them here and there, our factors. So we would say x times x plus 2. Now, some people, if they're really good with their math facts, they maybe don't need to draw out these little rectangles and think about what would make each space. Some people can just look here and know, hey, this is x times x, and this is 2 times x, and then, you know, they may feel very comfortable factoring by hand, just going, hey, look, man, here's an x, there's an x, let's pull that out, right? And then write the x on the outside, and then let's make a circle for what's left in here. So they'll say x times x plus 2. And that's another way to do it, right? Because they have the plus sign in there, right? So they see this is what's left is my x plus 2. I pulled out the common factors. So that's another way to do it. And if your eyes are really good, you know, this is kind of a really basic, simple problem here. If your eyes are really good, you'll be able to do that, right? If your math facts are really good, you'll be able to do that. But if you want, you can make these rectangles. And as these problems get a little bit harder, which we'll do a harder one here in a second, then you'll see that it's helpful to make the rectangle. So that's what I'm going to do here. I'm just going to, let's see, grab one of these, this one right here, boom, okay, and we'll paste this in here, okay, and I'm going to shrink it down a little bit, right, okay. So how do I factor a trinomial? So there's a lot of ways, again, to do this, but what I'm going to do is I'm going to make this rectangle, right? Now, here's the key, right? So in my rectangle, I see that I have an m squared. So I'm going to just make some space in here that would look like a square, and I'm going to call this m squared, right? And I'm pretty sure that's going to be m times m, okay? So next, I got to come over here, and I'm going to put this number, right, this back number, that negative 90, I'm going to put it down here in this corner, minus 90, okay? And so the trick here when we're trying to do these is to try to find, you know, what number, we've got the m and the m, right, and they multiply together to get m squared. What are the two numbers that we can multiply together to get to 90, right? And here's the key. This has a positive 1 in front. So here's my key question right here, right? So what numbers, let's say A and B, will multiply together to give me negative 90? But when they add together, A plus B is going to give me positive 1, right? So I'm trying to figure that out. What numbers multiply together to get negative 90? And you might have to make a list, like, okay, so I know 90 times 1, but they're not going to add together, right? Or negative 90 times times 1, or 90 times negative 1. That's not even close. They have to be really close numbers, right? 3 and 30, 3 times 30, but that's not close either. How about 9 times 10? Yeah. 9 times 10 will give me 90, and 9 plus 10 would be 19. Oh, but remember, we're looking for negative 90 and positive 1. So if I make this a negative 9 times 10, negative 9 times 10 would be negative 90, and negative 9 plus 10 would be positive 1. Now that I know that, I'm going to put the negative 9 here and the positive 10 here. And so this rectangle, this two-dimensional space, if it had a measure right here that was negative 9, right, and a measure right here that was 10, then this space right here would have an area of 90, right? This whole space in here, right? This would be negative 90 because that measure is negative 9 and this measure is 10, and we know we find the area here by multiplying, right? This one has a space, a measure of m, and another measure of m, and so its measure is m squared. So what would this space right here be? This corner over here, right? Well, this measure again is still m, and this measure is still -9, right? So m times -9 is -9m. And here I have this measure is still m, and this measure is still 10. And so if I multiply together, I get 10m. So now, what is the area of the whole thing? Well, the first part up in this corner, right, this is m squared. The back part in this corner was -90, and we planned it that way, right? But here's the trick. These two parts, this part here, oops, let me get this here. Make that a little bit bigger, okay? This part here and this part here together, we add together those areas, and you have 10m plus -9m equals 1m. So it would just be plus m. And that's my original trinomial, right? So my little test worked. Right? These are like little puzzles. You can just sit and do them for a while. The longer you do them, you start to get better at them, right? So these are the kinds of things that math teachers ask you to do over and over and over to practice so that you can learn these, right? So this dimension here is m plus 10, and this dimension here is m minus 9. And I like to say that this form is area form, right? And this form here, this form here is length times width. It's not really, I mean, they're just numbers and letters, so they're not really a rectangle, but I like to think of it that way because I find it's very helpful for a lot of kids to do it that way. Okay, I'll do one more, okay, just so you can see the process one more time. Let's go get another one of these. I'll take, let's try, this one right here. I have a number that is not 16. Okay, so here we go. I'm sorry, that is not one. And let's try that one. Let's just try this real quick. Actually, you know what? Let me do a different one. Let me scroll down here onto the back page. Let's take a number like this. So this is an ugly number. Oof. Let's try it. I'll do this one. Here we go. All right. So again, now this has a 5 in it. So it's going to be, let's see, maybe go this direction. I think I've been going the other direction too much. All right, here we go. Ready? Okay. So this 5 in here, boy, this is where it's really helpful if you know your times tables a little bit. But I know this is 5 times 1. And I know this -30 is 5 times -6. And I know this 40 is 5 times 8. And so this is one of those things where I have 3 terms, right? I have this term here's 1, this term here's 2, this term here's 3. So it's called a trinomial, 3 terms, and I can see that each term has a 5 in it. And so this is where I would factor out the 5. All right, I'm going to just draw the 5 over here. And what's left inside is going to be a trinomial, right? So what's left here is I have this 1, right? 1v squared. So I'm just going to write v squared. That's my first term. The 5 goes away, and I don't have to write the 1. This one has -6v, right? So -6v. And here I have 8. 8 is left, so plus 8. And that's because I pulled this factor 5, 5, and 5 out of each term, and I put it outside this circle parentheses, right? So now, that's my first step, and it makes everything else a lot easier, because now what am I going to do? I'm going to make my rectangle. Okay. And this rectangle is going to be not too bad. I know I need a space. I'm going to just draw these little squares in here. I need a space for this v squared. So I'm going to call this v squared. And I know that's v times v is the dimensions. And now I have, again, I'm looking for two numbers, a times b, that equals this, 8. And I know I'm going to need to put the 8 down here, right? But I need those same two numbers to add up to what number? What do they have to add up to? -6. And so now you got to think with your brain. If they add to negative, there must be some negative. But if they multiply to positive, then they must both be negative, right? They must both be negative. Because otherwise, it would be a negative times like a negative number times a positive number is going to be a negative number, right? But in this case, I want a positive number, +8, right? So it's got to be a negative times a negative to give me a positive, right? If I did a positive times a positive, I wouldn't get a negative when I add them. So I know I'm going to need two negative numbers. So what two numbers, when I multiply together, give me 8 and add together to 6? Well, there's 1 and 8. -1, -8. That would add up. That would multiply to 8, but it would not add up to 6. So I have 2 and 4. 2 times 4 is 8. And if I made them negative, -2 times -4, they'll add up to -6. So that's what I'm going to use. I'm going to go -2 and -4. So this area here, right, v times -2 is -2v. And this area here is v times -4, so that's -4v. And if I write down everything that I have in this trinomial, or in this area, and I complete this area, v, oh boy, let me erase that. All right, I've got this v squared, and I've got -2v, and this should be -4v. I'm sorry, I wrote x. -2v and -4v is -6v. And -2 times -4 is +8. So these dimensions work as the length and width of this area, right? So to finish factoring this, what I do is well, let me get a little bit smaller here. Here we go. Let me write the whole thing out. I've got 5. I knew that was on the outside. And then I've got my length, so I'll call that v -2. And then I've got my width, which is v -4. Okay? So that is how I can factor this trinomial. Okay, guys, that's going to be on you to practice this worksheet today. See if you can get all these done. You look for common numbers in here. I think I can see one right here that you can factor out. And here, you probably see one that you can factor out. And here's, you probably see one that you can factor out too. So as I look at these, I think you're going to be able to get through all of these today. But they're little puzzles, and they're not easy. So take it easy on yourself. Work together, right? And you'll be fine.